Mr. Borcherding wants to fit a 3-meter long car into a 1-meter long box for his wife for Christmas. How fast would he have to drive the car to do this? So, first things first, let's remember what all these things stand for, mostly L and L prime. So L is, again, the measured or the observed length by an outside frame of reference. L prime is the proper or the real length. It's how long the object is supposed to be. And that's measured by an inside frame of reference. So the 3 meters is how long the car should be. I'm driving the car, so I'm inside the car. So that's how long it should be. Okay, so on this problem, trying to fit a 3-meter long car into a 1-meter long box, how fast would I have to go? So L prime, and V. So L is the measured or observed length. How long do I want to measure the car to be? 1 meter. I want the car to measure to be 1 meter long. How long is the car actually? If you got in the car and you measured it, you would measure it to be 3 meters long. And then you want to solve for the velocity. So, 1 equals 3 times the square root of 1 minus v squared over c squared. And I know what you're saying. You're saying to yourself, Mr. B, I do not want to solve for this. This is terrifying. Don't be scared. I promise, it's fine. Divide both sides by 3. Okay, so we get 0.33 equals the square root of 1 minus v squared over c squared. I need to get rid of this square root business. So I'm going to square both sides. When I square 0.33 repeating, I get 0.11 repeating equals 1 minus v squared over c squared. I'm going to subtract 1 to both sides. So that gets me negative 0.89 equals negative v squared over c squared. Anytime you got negatives on both sides of the equal sign, they cancel. So divide negative 1 over so the negatives go away. I need to get v squared by itself, so you always multiply by the bottom to get rid of division. You multiply by the bottom. So I did a bunch of stuff really fast. Here's where I am. 0.89 c squared equals v squared. I don't want v squared. I want v, square root both sides. When you square root 0.89, you get 0.94. When you square root c squared, you get c. So, it is possible to get a 3-meter car to fit in a 1-meter box. You just have to go 94% the speed of light. Easy peasy.
How would you give her the box?
Don't worry about it. How would you give her the box? We would just, yeah. We'd just get outside, and I'd be like, all right, wait here. Drive the car real fast. And then for that 1 split second, it would fit in the box.
She wouldn't be able to. She get her a box.
Yeah, I wouldn't be able to stop the car, because then the car would go back to regular size.
Except where she opens it, the side will blow out. You'd be like, I got got you a car. I just had to drive it.
Yeah, exactly.
I mean,
It's technically true.
at that point, the car would just like bust. I mean, she wouldn't be able to perceive it going in
No.
the box.
All right. Here's what I want you to try just to wrap up here at the end. I want you to try number 3. Okay? That's all the homework is going to be, 1 through 3. That's it. 1 through 3. So I want you to try number 3 on the practice. Sagittarius A, the black hole at the center of our galaxy. By the way, that is the actual way it's written. It's written with an asterisk after it. That's the way it's written. I think that's to indicate that it's a black hole. Yeah. Sagittarius A, the black hole at the center of our galaxy, is about 26,000 light years away from Earth. If you flew a spaceship at 0.95 c, what distance would you measure the spaceship to travel? So be careful about what's L and what's L prime. Okay? Be careful on which is which. Remember,